So we have, guys, we got g of -2 equals 7. That's like me giving you the answer to one of the function problems, right? So the input was -2, which makes this x, and the 7 is y. So is there a coordinate pair there that has an x of -2 and a y of 7? And there it is, right? And then here, physics students drop a ball from the top of a 50-foot high building. They use this to model the height of the ball in relationship to time, right? Between what two consecutive integers does the ball hit the ground? Well, guys, what's the output value for height when the ball hits the ground? Not a trick question. Yeah, it's 0, right? What's the output value for height when the ball hits the ground? It's 0, right? So if I type this into my calculator, oh, by the way, this is a good time to talk about this. Notice what variable was used in that problem. It's 50 minus 16t squared because we're talking about time, right? Do I have to use t when I type it in the calculator? No, I can replace it with an x, right? It's just representative of whatever we're trying to accomplish. So I have 15, or not 15, I have 50 minus 16t squared, so we'll use, oh shoot. Where do I want to go? Graph. All right, and I don't even care to know what the graph looks like. I mean, I could if I want to. There it is. All right. In fact, if this represents the ball, right? The ball's on the ground right here, isn't it? Because isn't this a y value of 0? So between what two values does the ball hit the ground? Between 1 and 2. Now, if I go to tables, well, how high is the ball after 1 second? 34 feet. How high is the ball after 2 seconds? -14 feet. So somewhere between those, it must have hit the ground. So between 1 and 2. Good. All right, moving on. Guys, a lot of what we're going to do right here is going to be review. In fact, a lot of what we're going to do at the beginning of the year is going to be review, okay, from algebra. Maybe taking things a little bit further. These words are not unfamiliar, are they? We understand the word domain and range, right? Okay, what letter comes first in the alphabet, the D or the R? The D. What letter comes first in the alphabet, the X or the Y? The X, right? So D, which stands for domain, refers to X because X comes before Y and D comes before R. R stands for range, and so that deals with the Y values, right? Easy way to think about it, okay? So your domain, X values, your range are the Y values, right? So here, what do I tell you? I say that here's a function, f of n is 2n plus 1. And what are we going to do with this function? Well, we want to know the range. And it gives me this domain. What does that mean? It means these are the only x values that I'm allowed to use. That's what domain means, right? These are the only things that I'm allowed to use in this function. So I'm going to plug them in to figure out what the outputs are, right? Because for every domain value, I may have a range value that correlates, right? I'm going to plug in 1, 3, and 5. And when I do that, I'm going to get 3, 7, and 11. So the range is equal to, okay, this is one way to do it. Now, when I say one way to do it, I gave you a set of numbers, didn't I? What is the definition of a set of numbers? A set of numbers is what? It's just a collection of items, right? It's just a collection of items. Now, this set has how many items in it? 3. Some domains might have how many items in it? More than 3? Like how many more? Like an infinite number of them, right? Yeah, some domains will have an infinite number of them, right? This one happens to have a restricted number. Why a restricted number? Because the domain was restricted. Cool? Right? State the domain and range in the mapping below. So what does that mean? It means we use 1, 3, and 5. And those went to specific elements, 3, 7, and 11. I'll put 3 here, I'll put 7 here, I'll put 11 here. It doesn't matter where you put them. And then the mapping simply means that I'm going to do what? I'm going to draw arrows to what goes to what, right? So 1 went to 3, and 3 went to 7, and 5 went to 11, right? So that's a mapping. Domain and range. Okay, quick question. Hey guys, look at this graph. Does it have a beginning? Can you put your finger on where that graph begins? Again, I mean, be literal with me, guys. Don't think that I'm trying to like trick you. Can you put your finger on where that graph begins? Yes. Can you put your finger on where that graph ends? So if you can do that, the domain must not be what? Must not be infinite, right? There must be things that aren't within it, correct? Okay. So in other words, is -10 a part of this graph? No, right? I mean, this is -1, 2, 3. -10's all the way out here, and my graph clearly stops here, right? What would make this graph continue? If I put what on the end of it? An arrow, right? Yeah, so the fact that these don't have arrows is what makes it special, right? Okay, good. So what is the minimum x value? Well, the minimum x value is the one that is furthest to the left. The maximum x value is the one that is furthest to the right. The minimum y value is the one that is furthest down. The maximum y value is the one that is furthest up, right? So this point right here is going to be a min x because it's furthest to the left. This is going to be a maximum x because it's furthest to the right. This is going to be a what? Minimum y because it's what? Furthest down. And look at this, guys. Isn't this also the point that is furthest up? So isn't this also going to be the maximum y? So it's going to be the maximum x and y. This is the minimum y. This is the minimum x, right? Just going furthest left, furthest right, furthest down, furthest up. So the minimum x is -1, 2, -3. And the maximum x, 1, 2, 3, 4, 5, is 6. The minimum y is what? -1, 2, 3, 4, 5. And the maximum y is also, oh, it's not. It's 4, right? Because what's this coordinate value right here? This is the coordinate value 6, 4, right? Now, I have a quick question. Is there a specific number of elements in the domain? Can you count them? Well, let's see. It starts at -3 and it goes to 6, right? So is 0 in the domain? Is -1 in the domain? Is 5 in the domain? Okay. Is 4 in the domain? So can you count the number of items in the domain? Okay, now ready, I'm going to prove you wrong. Is 1.1 in the domain? Is 1.11 in the domain? Is 1.111 in the domain? How long could I do that for? Okay, so you get the idea, right? So even though there's a beginning and an ending, there's an infinite number of things in the middle. Okay, we all understand that concept. I know it's a little weird, but we get the idea, okay? So when I write the domain, I'm not going to write it with those like curly brackets. Those curly brackets gives me a set of numbers, right? When I use inequality symbols, okay, we're going to use set builder notation with inequalities. And here I give you an example of what that looks like. Okay, so the domain, here's how I'm going to write it. I'm going to write X, and then I'm going to put this line. That's just like a vertical line. Where do the X values begin? -3. Do they actually touch -3? Is there a point at -3? So what do I have to write? Less than or equal to. And where do they go to? What X value was maximum? 6. And they actually touch 6 as well, right? Okay, so that looks like it's real like complex and stuff, like the way I wrote that. But do you guys agree that this is the inequality that starts here and ends here for X values? And guys, all this other gibberish is ready? If this is an X, this is an X. And the way you read this is X is an element of this inequality. In other words, all the X's must fit in here. So if I want to do it for a range, what variable am I going to use here? So Y is an element of, okay, ready? This is where people are going to make this mistake because they're not paying attention. Ready? Here's the mistake. When you write domain, you always write it from least to greatest, furthest left to furthest right. When you write range, you always write it from least to greatest, furthest down to furthest up. So I'm going to write what? -5 to 4. What variable goes in the middle? The Y. Guys, star this. This is called set builder notation. So just give me like 2 more minutes here, and then I'll give it the last couple minutes to kind of hang out. I told you guys this was set builder notation, right? Is that the only notation that we're going to use to represent sets of numbers? What do you guys think? Because I'm telling you right now, on the first test, I'm gonna be real specific. You need to give me this answer as an interval. That's the other way, or in set builder notation, right? So set builder notation is the curly brackets like this, right? And then the other one is the interval notation. Now I sort of give you a quick little rundown of what that looks like below, right? So interval notation, and make sure you star this as well, because you definitely need to know the difference between the two, right? So here's what I want you to remember about interval notation. I'm going to go back up here to the domain and range, okay? All right, easiest way to do interval notation. Do you guys agree that I could put this on a number line? Right? I mean, I'm like talking about going back to algebra class for a minute. So I do a number line, -3 goes on the number line, and 6 goes on the number line, right? And then I would put some circles. Now, are those circles going to be filled in, or am I going to leave them open? Why am I going to fill them in? Filled in means that you are allowed to have them as part of the solution, because it says what? Less than or equal to. So filled in means it's equal to, right? So I would have a filled in circle, and I would have a filled in circle. And do you agree that the answers lie in the middle of that? Okay, so it would look something like this, right? And so the next one would be really easy to do as well. It would look something like this. So no problem. So when we do interval notation, here's the way I like to explain it. Where does this interval that I just drew start? -3. Am I allowed to be -3? If I'm allowed to be -3, I'm going to use a bracket. Comma. Where does that interval end? Am I allowed to be 6? So I put a bracket. And there's your first interval. So the next one would be no problem at all, right? Starts at -5, ends at 4 with what? With brackets on both. Anybody surprised by that? No. So what if I then did these two things? Just kind of jot these down here. I want to do x is less than 4, and I want to do x is greater than or equal to -1. So if I asked you guys to put those on a number line, well, this one would look like what? You would have, oops. You would have 4. We would have what kind of a circle on it? An open one. And what are values that are less than 4? To the left or to the right? To the left. So if I asked you guys to now write the interval, where does this graph start? Well, this arrow means it what? Keeps going to the left. And it keeps going to the left. And it keeps going to the left. And so the answer is it never starts. But where does it begin? -infinity. Hey, guys, quick question. Can you put your finger on -infinity? So can you ever get there? So can you ever equal it? So can you use a bracket? What do you have to use instead? Parenthesis. Starts at -infinity and goes until we get to what? 4. And are we allowed to be 4? So we use a parenthesis. And how does this last one look? Well, I have my number line. I start at -1. And I want values that are greater than or equal to, which means what kind of a circle? Closed or filled in and shading to the right. So last thing of the day, where does that interval begin? -1. Am I allowed to be -1? So I put a, and where does it end? Infinity. Am I allowed to be infinity? No, so I use a. Outstanding. Have a great weekend.